Hey everybody, Mr. Covey here, and today we're going to do some math. Specifically, we're going to do 10-7 and talk about inscribed and circumscribed polygons, which we talked a little bit about more, but we talked a little bit about them, we're going to talk about them more, and we're going to look at some special relationships that happen when you have quadrilaterals inscribed in circles. So first, let's make sure we're good with the vocab. So a polygon whose vertices are on the circle is said to be inscribed in the circle. Okay, so this picture we have here, the polygon is inscribed in the circle. Okay, what that means specifically is not just inside, but it means that the vertices, all of them, are on the circle. All four vertices. Again, the way I remember it is inscribed is inside. Okay? If we could, we'll come back to this definition down here, but I want to look at the other situation first, which is circumscribed. Okay? So in this picture here, we have a polygon whose sides are tangent to the circle. Those are the points of tangency, those red points there. And here we'd say the polygon, in this case the triangle, is circumscribed about the circle. Just like I think about it as inscribed as inside, I think about circumscribed as outside. Okay, if you could flip back to the previous picture with me. First of all, this definition here is flipped around. It was with a different picture in your notes. So if you could please cross out what's there in your notes and write down this definition. And what this says is the circumcenter is the center of the circle circumscribed in a polygon. And what this means is that the center of this circle has some special properties, and we call it the circumcenter. And we'll talk more later in the video about what those properties are. Just one point of clarification. To describe this picture, we could say the polygon is inscribed in the circle, or we could say the circle is circumscribed about the polygon. So it just depends on your perspective there. Okay, so make sure you're clear that you can reverse those ideas. Here, if we have a circle inscribed in a polygon, then we call the center of the circle the incenter. There is a connection between the incenter and the circumcenter that we talked about before, relating to triangles. And we'll talk about that in class. Let's do some example problems. In order to do these examples, I'm going to tell you some important relationships that happen when we have inscribed and circumscribed polygons. So first one, if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. I'll give you a little bit of quick convincing. Let's say angle BAC was, for instance, 100 degrees. Well, then arc DC or BCD would be 200 degrees because angle BAD is inscribed. And if that arc was 200 degrees, then arc BAD would be 360 minus 200 would be 160 degrees, that arc. But then angle BCD is an inscribed angle coming from that 160 degree arc, so it would be 80 degrees. So rather than doing this process over and over, you can just remember this theorem that opposite angles are supplementary if a polygon is inscribed in a circle. Cool? Okay. Now, if a parallelogram is inscribed in a circle, then it actually must be a rectangle. Okay, so you can try all day to draw a parallelogram that's not a rectangle, but it will never be actually inscribed in the circle. One other thing, do not write this down. I just want to be very clear. Don't write this down. Bad rectangle, but that does not count as inscribed because all 4 vertices are not in the circle. So while that rectangle is inside of that circle, it is not inscribed in the circle. So please just be clear about the difference between inside and inscribed. Okay, so let me draw a proper one here, and you can draw this too. So if we do have a rectangle that is inscribed in a circle, and we know it's a rectangle, first thing, so let's label our vertices. And we'll call the center O. We know a bunch of things. First, BD and AC are diameters of the circle. Okay, so the diagonals of your rectangle are diameters of the circle. O is where the diagonals intersect. And also the center of the circle. So where the diagonals intersect and the center of the circle are the same point. Third thing, OA, OD, OC, and OB are all radii of your circle. So again, these are facts that will help us solve problems when we see pictures like this. Those are all radii. And lastly, because we have right angles, we can do a bunch of different Pythagorean theorem calculations here. So I'll just give you one example. For instance, AD squared plus DC squared equals AC squared. And there's lots of different Pythagorean theorem, lots of different right triangles that you could do Pythagorean theorem with. Cool? All right, let's do a few examples here. So in this problem, they're telling us arc ADC, it's 134 degrees. Angle A, 104. They want us to find angle D and angle C. I'm just going to start filling in stuff that I know. Well, this is a quadrilateral inscribed in a circle, so opposite angles are supplementary. So angle C must be 76 degrees. Angle B is an inscribed angle who intercepts a 134 degree arc. So it must be excuse me, 67 degrees. And now if I want to find angle D, well, I know 3 angles. In a quadrilateral, all 4 of them have to add up to 360. So if I do 360 minus 104 minus 67 minus 76, I get that angle D has got to be 113 degrees. Alternatively, I could say angle D and angle B are opposite angles with a quadrilateral inscribed in a circle, so they have to be supplementary. So 67, 180 minus 67. All right, next problem here. It tells me it's a regular pentagon. Well, regular means all sides and all angles are congruent. You'll remember from earlier in the chapter, if you have congruent chords, you have congruent arcs. So all those arcs must be the same. Wants us to find the measure of arc PQ and RST. Well, the whole thing's 360. It's divided up into 5 congruent arcs. So each arc is going to be 72 degrees. So then arc PQ would just be 72 degrees. Arc RST, well, that's just going to be 2 times 72, so it's going to be 144 degrees. couple more problems here. I'd like you to pause the video, solve this problem, and then unpause it and check your answer. Okay, the way I did this problem was I used the idea that the opposite angles of a polygon inscribed in a circle are supplementary to set up this equation and this equation, solve my system. That's what I got for x and y. Okay, last problem here. This is from the book. It's on page 490, number 11. It tells you that you have this trapezoid that is circumscribed about the circle. Angle x and angle y are right angles. XW is 16. Make sure I note that that's that whole thing there. YZ is 7. Oops, sorry. And it wants us to find the perimeter of this trapezoid. Now, something that's cool about polygons being circumscribed about circles is basically we have a bunch of ice cream cones, if you remember from earlier in the chapter. So, for instance, these two segments are congruent. These two segments are congruent. These two segments are congruent. And these two segments are congruent. So we can use that idea to help us here. For instance, I'm just going to call both of these A. Well, then I'll call both of these B, both of these C, both of these D. Okay? So what I do know, based on what they told me, is that A plus B is 16, and C plus D is 7, and that's about it. I have 4 variables and 2 equations. I cannot solve this system here. However, we've seen problems like this before. I actually don't need to figure out what A, B, C, and D are, because I just want to know the perimeter. And the perimeter, if you look at it, it's 2A and 2B and 2C and 2D. If I use a little factoring here, I can rewrite that like this. And I can actually say, oh, knowing A plus B is 16 and knowing C plus D is 7 is actually enough. I don't need to know what they are individually as long as I know what their sum is. Plug those in there, and you get that the perimeter is 46. Again, that's kind of weird. It's one of those problems where we figure out something, like in this case the perimeter, without ever actually figuring out the values of A, B, C, or D. So just be aware of a type of problem like that. And that concludes 10.7.